So welcome to the Node.js Node API team meeting for 2020 or January 21st, 2022. Just because you can't see everybody who is here, I'll just say it's like myself. It's Legendikas, Gabriel, Jack, Nicola, and Vladimir. And we will pull up our milestone 11 to take a look at. But before I do that, does anybody have any announcements they'd like to share?
Yes, I just released the new version of the Dawn API, the version 4.3.0. This release added some new API, the iterator for NAPI object API, and some work on the error class, and some other fixes on the test and documentation. So yeah, this is what I want to share.
Okay, well, thanks for doing that. And it's great to get that new release out. Just looking for your tweet, which I just found. I'm retweeting that to get the news out. Some of the new stuff is there, so thanks. Any other announcements?
I just want to share that my work on Hermes, implementing an API for Node API for Hermes JavaScript engine, seems to kind of about to be finished. So already have some draft pull requests out, and currently working on finishing up unit test suite. And my hope that after this unit test suite being applied to Hermes Node API, and it's previously been applied separately to V8 JavaScript engine, hopefully we can start to work on towards this vision of having this unit test suite in a separate repo, as we discussed a few months ago.
Yeah. Oh, good. Sounds good. Okay. Anything else before we go look at the issues tagged for this week? If not, okay, I'm going to share my screen here. And I think that's it. So everybody should be able to see that now. Just grabbing my kit here. Okay, so the first one is one that I added. This is actually a PR related to a PR to add a new API to Node to the Node API in Core. And there was some discussion, and it reminded us that, in fact, our guidance says we need to, before we add something, we need to discuss it in a meeting. So here we are in a meeting. This is adding Node API symbol 4. Basically a method to help get symbols more easily. I mean, the discussion, there was also a PR for another one, which added like 5 or 6, maybe 10 new methods to add symbol helpers. And sort of the consensus in the issues there was like, well, that was going too far, because like our guidance is like, we're trying to keep Node API fairly tight. So it shouldn't have like a whole bunch of helpers and all that kind of stuff. That stuff should mostly be in Node add-on API. But we did figure that getting a symbol was, a common enough thing that one method actually still made sense. So that's why this one is still like on track for landing, unless, people have objections. And the other one, we kind of said that was straying too far into the, sort of helper things that you can, and adding lots of methods. So I don't know if anybody has thoughts on this one, concerns.
Just a quick question.
Yeah.
This new API accepts a description as a const char, and we have some other APIs, especially concerning creating new strings, and they typically have size. And if we really want to have a zero terminated string, we typically say like auto length. So
Right.
my question, like, would it be worth to have this API specify length of the string?
Yeah, that's a good point here. So let's take
I don't know. It's just asking your opinion, just kind of being aligned with some other APIs we have.
Yeah, what's another example is
Like if we have, say, create string Latin1, for example, an API create string UTF-8.
right, we have this auto length, right?
Yeah, auto length in case if you want to be zero terminated, or you can specify explicitly what your length is supposed to be.
Yeah.
My question, I guess, back to you, if you think it's worth to have a length as a special.
That makes sense to me.
Yeah.
I don't know what other people think.
Yeah, I agree. Yeah, it's a good observation. We should be consistent with other APIs.
So, okay, so let's, I'm going to. So I guess it's like, any other concerns? Like, cause I could comment in here, we discussed in the meeting, people sounded, okay with adding it, but this was the suggestion that came out. Is that, or does anybody like, hey, no, we shouldn't add this?
No, I'm definitely okay. I don't know about others, but I'm definitely okay with adding this if it's something that cannot be resolved with existing APIs. And if we do add it, we should have the length.
Yeah, I think it's one where it's like you could do it by running JavaScript because you can do anything, right? But
oh yeah. No, I mean, yeah, short of executing a JavaScript block.
No, technically you can do it using an API, but it's many kind of steps. You first one need to create string using one of these APIs we just discussed, right? And secondly, you need to get a global object. Out of this global object, you need to take symbol constructor.
Right.
Out of symbol constructor run this static method for the string. It's like you literally need to do like 5-6 steps in an API.
I have to check the implementation. So but this uses like a V8 API, right? Internally, I haven't gotten that far yet.
We could take a quick look. It should be in here.
Yes. It uses V8.
Right.
So it uses V8 symbol 4, which makes sense. Okay, yeah. So we're exposing a V8 API here, so that's good. And we need not worry about other engines because all those can just do what Vladimir just described.
Right.
And another concern, we need to probably in this API explicitly say what this string encoding is. Like, is it Latin1 versus UTF-8? I assume it's UTF-8, but we need to make sure that the API explicitly says it's UTF-8 string.
Yeah, it's descriptive.
I was thinking that this API is only accepting UTF-8, whilst we already have string constructors with an API that we could create a string with UTF-16 or Latin1. So what about the other encodings? And I'm thinking that it will be better that the API could accept another string, probably.
Right. Instead of a const char, that would be like an extra step because you would actually have to create a string in, and it would create an object like that. I think creates a JavaScript object, right? Which then needs to be garbage collected.
Yeah, so it is documented to require a UTF-8 string. So I guess I don't know. Do we have other APIs that take in const chars and produce things like aside from creating strings, because their encoding is definitely important, but like for different purposes than just encoding strings.
Yeah, here I'm just trying to share that here. So like
create function. Create function uses UTF-8 name. The name of the parameter is UTF-8 name. So yeah, that's another suggested change, is to change the name of the const char start parameter to UTF-8 name or UTF-8 description or whatever. But so we can only, so for example, to create a function, we can only use a UTF-8 encoded string. We don't have a create function Latin1, create function UTF-16.
Right.
So I think our convention is that if strings are not the point of the API, then the string must be UTF-8 going into Node API.
Sounds great.
Because it seems like it's probably the most common, and I guess at the C level you could convert, right?
Presumably there would be conversions. I'm just thinking if it might make sense to add a variant that accepts an NAPI value that is a string.
If that's not the common path, people can always fetch the JavaScript symbol object and create, like say, get it from the global and call it as a JS function. Since then, they can use the NAPI string create from that one or
Yes,
UTF-16.
yeah. That's why I'm saying, like so now you have two choices. Either you provide a plain C UTF-8 string, or you go through all those steps of retrieving the global, retrieving the constructor, creating the string, and then retrieving the symbol. So it might make sense. Like, so if you are stuck with non-UTF-8, then you have to go through all that, right? If we provided an API that is able to get the symbol for an API value that is a string, rather than get the symbol for a const car star that is a UTF-8 string, then you could do it in 2 steps, right? You create an API create string on UTF-16, and then an API symbol for something, and then you pass it in there. So it's still better than having to go through the whole process of retrieving the global, etc., etc. And it does give you the option to use differently encoded strings as the lookup parameter.
All right, just a question. On our Node add-on API side, do we need to adapt our API to this once this lands, or?
Probably, yeah. We'd want to cover it.
Okay, because right now that one also takes a NAPI value as this parameter on our side.
So the symbol for, eh?
Yeah. Yep. So it takes string, const char, the string object, and NAPI value.
Cool. Good to know. Yeah. Okay. So we only have an API create symbol.
If I understand correctly, it's UTF-8 description, and there is no UTF-8 name, right?
Yes.
Right. Right, like this.
Yeah, and we don't need the UTF-8 name since we don't have this parameter.
So is this what you're suggesting, or?
No, we
I
remove
mean,
this.
yeah, we can remove this line.
Oh, right. Okay, yeah, okay. Yeah, right. Right, just this.
Yeah. So what do you think? Should we ask that other API be added, like Node API symbol for value? Let's say we can bike shed on the name that accepts an NAPI value.
I would probably use it. Can we kind of like we have a precedent in our Node existing API? We have a set property and we have a set named property, right? And the difference, like set property using value, well, like a named property uses UTF-8 string.
Yes, that's true. Yeah.
Looking for the.
They are, if I recall correctly, these 2 functions are have different semantics. One is a shorthand for setting a property, like say data property, and the other one we can define a property with property descriptors. So they are doing different things, but if we add another variant for symbol 4, but they are doing same thing, but for different parameters.
I think Lucas, you're thinking of an API defined property. We're talking about set property, which is an API env, an API object, an API key, an API value. So set property does what Vladimir says, which is to use an API value as the key, whereas an API set named property uses a const char star UTF-8 string as the key.
I mean, I guess in my mind, how often will we already have the symbol as a value versus a string?
You mean the description?
Sorry, well, the const char description.
It's not necessarily for use cases where we already have an API value that is the string description. It is for use cases where we have a const char star that is not UTF-8 encoded, right? In those cases, you have to go through the two-step process of an API create string something other than UTF-8, either Latin 1 or UTF-16, and then you would say an API or node API symbol for value, and then that.
Well, or why wouldn't you just convert it at the C level from UTF-8 to whatever it was to UTF-8?
How easy is it to do that without linking to an external library? Then you'd need to introduce, if you don't already have it, you'd need to introduce a library dependency for the sole purpose of working around this NAPI thing, whereas it already has a conversion inside V8. It already has like a conversion library, basically.
Yeah, I'm just like, just thinking
okay,
through. Like,
there is another workaround. There is another workaround. You can say an API create string UTF or create string UTF-16, and then an API get I forget what the name is. An API gets string value UTF-8, and then you're using V8's own conversion library to re-encode the string, and now you have the string, and now you call whatever you want. You call node API symbol 4. So then that would be 3 steps.
But you need to allocate some buffer. So think it's 4 steps, because you need first of all get the length of the string, then allocate buffer, read the string.
Yep. Yes. True. Yes. You're right.
I guess I'm just thinking, coming from the perspective of, aren't most of these, like when you create a symbol or whatever, are we really going to be getting it from somebody else? Or is it like 99% of the time just going to be like, hey, I want to define a symbol that I'm using, or it's a well-known symbol, in which case is just like, a const char star is exactly what you're going to want to do.
UTF-8 encoded.
Yeah.
I think that's kind of a good point. I think correct me if I'm wrong, the use case here is where you have different entities in control of creating the symbol versus using the symbol, and then they agree on the name of the symbol, and then you retrieve it. And so, like, you need to retrieve a property based on the symbol, like a symbol keyed property or something like that. And then you need to know the symbol, and so it's kind of an API between two, organizations, entities, pieces of software that communicate to each other using this well-known symbol, right?
But they'll typically, I'm just thinking typically like they're fixed, hard-coded, whatever, right? Like.
Yeah, you're right. Like the const char star might appear in a header file, which they both include.
Right.
Yeah.
Like, it's kind of like, I can see it common enough to say, okay, I want to get a symbol. I know its name. That I can imagine being useful enough. I'm just trying to figure out, is it common enough that I needed in something that I couldn't have in the UTF-8?
There's
Worth
another
adding
use case.
API for that.
There's another use case where the string might be dynamic if it's like a UUID, you know, to create like a really obfuscated property that doesn't normally show up if you like, you know, just dump the object and then check its keys and stuff. And then,
But even in that case, why not have that be UTF-8?
Yeah. I mean, most likely it's going to just be plain ASCII.
Right.
In which case it is UTF-8 de facto. Yeah. Well, I mean, look, we can always add it later. I mean, it's additive, right?
Yeah.
It's semper minor. We can add it
Yeah.
if needed.
I'm just like, you know, let's not add more than we really need to.
Yeah. Okay, good point. Yeah. I mean, it's totally open to yet another PR if needed.
Yeah.
So about length, just kind of quick question. Would it create additional issues if we call V8 API? Like, does V8 API allows to specify length?
Yes. I mean, that's how we do it for regular strings, right? So, I mean, if you look at the implementation, I can scroll the shared screen, but I can't scroll my own copy. So here we go. So on the, so in the implementation, it actually creates a V8 string.
Oh,
So, and it creates it from UTF-8. So it says check new from UTF-8. It uses that macro. So it does create a JavaScript string first, and then it gets the symbol for the JavaScript string. So internally, it does do that. So then, however we create a JavaScript string in get string or create string UTF-8 is the way we would do it here.
It does. Even if we're creating a string here, it is less Node API round trips.
Yes, that's right.
Like it's more expensive to create it in the other side.
Yeah, let me see. I think create string UTF-8 is not a preamble one, right? Because it doesn't call into JavaScript. So I mean, the implementation of this API could fairly cheaply call an API create string UTF-8 instead of calling like check new from UTF-8. Or it could just duplicate the implementation, or it could create an inline and they both call the same inline. There are a million ways of implementing it. Because it is partially a wrapper around existing Node APIs, right?
Right.
The string creation one in particular. So it could call the string creation one, and if that doesn't return an API okay, then this just returns that guy's status. And it would still not be slower. It would be just minimally slower if it did that.
But I don't see any reason to do anything different than what's there.
Well, I mean, if we add the length parameter, which I think we should, then it turns into a copy of an API create string UTF-8, right?
Right. Okay.
So that's why it may just be simpler to just call that function and then just say JS value from V8 local value V8 symbol 4 and isolate, and then V8 local value from JS value, and then description string. You know, after having called
this one right here. Right. Okay. So that's right. Okay. So basically the suggestion is copy link address.
Yeah. So add the length parameter, use the existing API to create the JavaScript string, and then pass it into V8 symbol 4. And okay, back in the day we had a security vulnerability with strings, but I think that was for retrieving the string, right? We had some buffer issues which we fixed, right? So it wasn't the creation that was the problem; it was the retrieval of the C string that was problematic, right? So, okay, I'm just trying to remember, because in that, or do you remember, Michael?
I don't remember off the top of my head.
We had to bubble it all the way up to no data on API. Yeah, I think it was the retrieval of the string. I can double check. It's, blame the header, or not the header, the implementation.
So does this sound good in terms, if you can sort of check that asynchronously and otherwise, this sound like a good comment for us? It'll be added as experimental. It's being added as experimental as well as per our general policy.
Oh yeah, yep. And maybe change the name of the parameter to UTF-8 description instead of just description, to make it clear that it has to be UTF. Oh, you did there.
Yeah, which is in there. Yeah, I've got, we basically said it's okay. We want to take a length, and here's some tweaks for the parameter names.
Yeah, okay. It should be snake case though, UTF-8 description for consistency.
Sorry, like this.
Yep.
Yeah. Okay. Let me.
Oh no, I'm sorry. No. Oh, sorry. No, it's just written as one, but not in camel case, because we have UTF-8 name, which is just all lowercase.
Okay.
UTF-8.
Right. Okay.
See,
so I messed that up when I like that.
Yeah, that's it. Yeah.
And then, and then also the suggestion that the implementation use the create string UTF to create this JavaScript string, since it already handles the length.
Yeah, and then we don't have two different places where we create strings in potentially two different ways.
Yep. Yeah, no, that's good.
Yeah, that's good.
Everybody okay if I push the button?
Yeah. Yes. You may also want to like request changes, because like 5 different people have already approved this, so you don't want this to land.
I think I already marked it as blocked on the, where are we here? So this is back to the conversation. I had it blocked on like the review of the team. Yeah, up in there.
Drag over.
I don't know what happened, but
so yeah, there's no request changes right now, so this might accidentally land as is.
Sure, I'll say okay. Request changes.
Yeah, I think you need to go back to the
right.
files thing.
Okay, requests. Yeah. Okay, we good on that one?
Yeah, looks like.
Okay, so let's go back to, am I going to be able to get back to? Okay, this one I'm going to close out, discuss that. Good, and then can I go back to, right, okay. The next one is stale issues. Let's take a quick look. This is the last one that was added a while back. I don't think I haven't seen anything new on that one. I don't know if there's any updates. No, I'll leave it on the list. This one.
I put in the end this big block from.
Okay.
So what happened? Like I was looking through this standard myself, and also I asked our internal Visual C++ discussion group, special interest group, and I have a bunch of different ideas and stuff. But anyway, on the surface, what it pretty much says, like if we have const qualifier for a function, const qualifier effectively affects how this pointer looks like. And there is technically, if somebody tries to modify const fields, they may kind of observe some kind of called undefined behavior. And for example, Visual C++ can just simply put some const fields inside of a read-only memory. If you scroll down a little bit, there is a kind of sample of the programs, like one of Visual C++ developers has shown. Like you see this, pretty much if field is not marked as mutable and the object itself is const, as you see, like for the case S2, any attempt to modify it, like through this const cast, may cause write access violation because compiler can optimize this field. Right? But in our case, I'm showing this pretty much how, in our case, this code might look like, just kind of as a sample, if you scroll down a little bit more.
Sure.
We don't really modify any fields. We pretty much just use this field, which inside of the object, this field we never modify. We pretty much modify whatever this field points to. And according to most people on this discussion list, people said that we're not doing anything illegal. And as you can see, this code is written here. It runs and compiles without issues, and we don't do any kind of const cast casting here and stuff. It just works. So.
Okay.
Well, summary.
Go ahead.
A summary is actually, if we mark all methods const, we don't really violate anything. And as we talk about any possible code optimizations, I didn't find any explicit clause anywhere inside of standard, but standard pretty much says like that pretty much implementations means like if they have any kind of implementation specific optimizations must not change any kind of external observable behavior. So I would say if based on a const qualifier, they decide not to call certain methods, they would actually may change externally observable behavior. So good compiler implementation will be prohibited to it.
So the optimization can't change any, right, any externally visible behavior.
So const qualifier in C++ does not say that is not the same as saying like we retrieving some immutable value. So it has different semantic. It's only kind of has guarantee about content of the class itself, like fields in this class, but does not provide any guarantee if these fields point to something else.
I'm thinking the const tends to be sort of viral. If you like, let's say, like for example, one classic example is trying to do like memcopy, right? Memcopy takes void star, not const void star. So if you have a const void star as the source, right, then you still have to const cast it because the compiler will complain, right? Because in memcopy takes a plain void star even as the source, even though it doesn't modify it, it's not declared as const, right? So I'm wondering if introducing const will have the same issues, because like let's say you have const NAPI : value, right? Now you pass the underlying value, which is not marked as const, right? You pass it into a node API, like a C API, right? Now the compiler is going to complain because the C API isn't defined as const NAPI value, right? And so the NAPI value is stored in a const class, and therefore when you pass it into the C API, it takes the const miss with it, and it will be passed in as a const NAPI value.
If you scroll all the way down to this example, like it's what I try to kind of emulate this behavior in small. Let's look at this. So first three lines with the code is pretty much analogous to what we have in a node API. Like I say, we have get property and set property, which accepts just okay, it's not void star, but imagine it's like void star, right?
Yeah.
Because it's just for brevity. I want to have something which like very minimal and it works.
Okay.
And now we have C++ is a wrapper, and we can see, say, this S1 star as a field, and we can pass it, and even down below in main method, you see the CPP value is declared as a const.
Yeah, as a const. Good. Okay. So this works. Okay.
Right.
Okay. Yeah.
I'm
Okay,
still
cool.
confused about the const, the statement about the const in the example. I have stated in about that why the current way we mark it as const is working is because we define NumPy functions as C declarations, and we don't have const marks in C declarations. So
Yes.
C++ compiler doesn't just simply ignore the fact that we are calling non-const C++ function in our NumPy implementations. So the fact is that we are if we mark this method as const, then we are calling non-const C++ functions from const C++ functions, which I was understanding is violating the C++ semantics.
Vladimir, I'm wondering what flags did you compile this with? You know, like if you compile this code with the strictest possible C++ flags, would it not complain about constness?
I tried like different compilers, like says C++ 14, C++ 20, and it was like permission minus. I used to do it in Visual C++. Could you try this small example with self-contained example? So technically, ideally, if you just simply copy and paste it and compile it to your compiler, you should see it's working program.
Yeah,
probably just missing.
That's a good challenge. I will try to find a combination of flags which breaks it, and if I cannot find it, then it is indeed a good example. Okay, so this is
any attempt to modify a const object during its lifetime results in undefined behavior, but I don't think we're talking about marking objects const, are we?
No. I'm just worried that with certain very strict flags, it will pass the constness of the pointer into well, it does pass the constness of the pointer that is stored inside the const object into the C API, but only with certain flags does it complain when you do that. It always does that, but if you don't have like a -w something set, then it doesn't care that it's doing that. Whereas if you do have the -w something set, it does. So that's what I'd like to see. And double check if there is such a -w something.
And just to be on the same page, the proposal here is put const in the end of function kind of methods. So in this case, our value object can be used, say, in some lambda captures and stuff, because all lambda captures by default is actually const, unless we say mutable qualifier in the end of lambda.
Yeah, so I understand the motivation, but my question is that we are calling why the reason we are adding the const mark in this method is that we are trying to calling this method from const lambdas, but the fact is that this method is calling the properly non-const engine C++ implementations. So that's why I'm very concerned about marking this method as const since it are implemented as non-const.
Right.
Is there anything that defines, like I'm looking at this part, class member function accesses the state of an object of the class, but does not alter that state. What I think it comes down to is the definition of the state of an object.
In our case, literally, if we look at the value object, state is only an API value. Effectively, the pointer of this value object store. So technically, as long as this method does not modify this pointer wrapped by kind of value class, we should be fine from this definition point of view, because what we saying that we call in some C functions which do something around this pointer.
Right.
But we don't really modify this class. Right? We do have, for example, const method can always call like printf and kind of print something to your console, right? It's
Right,
it
yeah.
obviously defines something, but not inside of our class.
But I guess it's like, is there somewhere in the spec that specifically says that? Like if the spec had a section that said the state of the object is just the in-memory representation of the object itself. For example, calling a method on an object that it points to, which changes the state of that method, does not affect the state of the object. It's that transitive state is, I think, what we're talking about, right? Like, I understand it. If we don't change the pointer, but does the spec somehow confirm that that's the definition of what the state of an object means? Like indirect state doesn't count.
Right. I guess there is a kind of definition. They never declare a class. So technically, the class says like it has effectively different members, including fields. So technically, state of the object is just fields inside of this object. So it's just the way kind of C++. I can probably find what exactly this class definition is, but it's I guess it's no difference from what in C. If you take a struct in C, so technically, content of the struct is the only thing which really controls it. So your field inside of your struct can point to some mutable, another mutable struct, if you will, right? So imagine you have one struct which is like in read-only memory, whereas like you have another struct leaving some writable memory. So you potentially your read-only memory can point to this mutable memory somewhere else.
Right. So I'm just like, if we had something, I'd feel more comfortable if there's like somewhere in the spec that said the state of the object is restricted to this and, doesn't go into the transitive state, because then it at least says like this observer function, that is like they're automatically marked as const, or this is something that the compiler marks const.
So here's just kind of definition. It's pretty much they just. I tried to look for the spec to find something that was unfortunately not so much about this const stuff. And this was one of the things I found that this observer function, something what the spec uses in some other text down the line. But I just felt like I can put here for completeness. Yeah, mostly saying what somehow like what const really means sometimes. It's more like to define a term in this point. But what really kind of, if you look on the spec, what's really important that constants on the method pretty much says how exactly this pointer treated inside of this method, what it exactly means, and what it pretty much says that it's a pointer to CV qualified sequence X. So technically, it's a pointer to const qualified X. So technically, if you have a const on a method, it means it's expecting that the whole class was declared as const, as we can see, for example, in this example, const S1. So technically, it assumes that this pointer points to this const object, if you like. Yeah, I kind of feel like I'm trying to interpret standard. Right.
I guess like I'm looking at this example. So struct CPC value. So we call set property. I wonder if like if these were like, if we actually had a struct, well, if we had a class with a pointer to an object and then calling methods and we make a constant. So we like what you've got here. We've got a class which has const methods. If those const methods then called a C++ object that had, it basically has a pointer to another C++ object. And if we called a method which was non-const on that pointer, if the compiler doesn't complain about that, then
okay, I can modify this example, but it's pretty much the same as what we already have. Because in C++ struct in class, the interchangeable keywords is just control default visibility of the members. Class says default visibility is private, and struct says default visibility is.
Right. I was just like, these are not part of like these methods are not part of a pointer that this class points to, right? Or unless I'm reading that struct. Okay, no, are these?
So say set property, you see we modify member, let's say, of another class. So it's pretty much as we would call non-const method. And you see we don't do any const cast, like it's
Right.
totally legal to do it. So this field S is a pointer. So if while the CPP value itself is const, but this const memory effectively has a pointer to some object of type S1, and this S1 effectively can be modified freely, even it's initiated from const methods.
Right. Yeah, so it's.
I'm sorry, but
okay.
I'm a little bit confused about it. Is that if we can't call const, if we can't call non-const C++ functions in C++, const C++ functions, then why should we allow calling a C function which delegate into a non-const C++ function in a const C++ functions? And I know they are why C++ compilers allowing this is that we have to make this C++ programs to be compatible with this C headers defined APIs, so that we can reuse this C headers defined APIs without any modifications. But if in the fact is that we are calling non-const C++ functions in these C APIs, we know that even though that C++ compiler don't complain about that, since C++ compilers have no knowledge about it, if these C functions are calling non-const C++ functions. So it's the fact that this C functions is calling non-const APIs, then why should we to escape about the rules that const C++ function should not call non-const C++ function? Why should we break the rules in these conditions?
So
right, I guess you're saying why does the compiler not let me call a non-const method on something else?
I mean, compilers are definitely not allow us calling C functions in our C++ functions marked as const. But if we don't have these C++ definitions in between the non-const C++ function and this const C++ functions, then compilers will complain about it. So since currently we have an API C declarations in between the engine and the node add-on API, and the C compilers have no knowledge about the engine's implementation, since we only expose the C headers which don't have like say const marks in C headers. So the C++ compiler just treat this C function as just C functions and just allowing calling it in a const C++ functions.
I just chatted in the chat, which I think is maybe what you're kind of asking, like, does the compiler complain in this case? Like if class A has method X, which is const, class A also has a pointer to B, B has a non-const method Z, would the compiler complain if X was calling Z?
So my answer to this question is yes.
Yeah.
It's only time when it will be prohibited when if this pointer to B itself declared as const. So for example, in this small code as we see on screen, S1 pointer is not const. So technically any methods on S1 object S, even if it's a non-const, are allowed to be called.
Right. So, but I guess I didn't quite follow. Are you saying that X can call Z if B is not a const object? Or
Yes.
that the compiler will still complain?
So my answer is yes. To your last question, can X call Z? The answer is yes, it can.
Right. Okay.
And
so if it doesn't complain on const in that situation, then that seems analog. That seems to be the same case as us calling into JavaScript. Like I'm calling a non-const method on some other class that's not in the class, that's like not affecting the contents of the actual immediate of basically A, right?
yes. I can provide this pretty much as you wrote in this description. Let me add later today example just concerned with C++ classes, if you like.
Right.
But I kind of 99.999 sure that sure that its answer is yes.
Because I think if the compiler allows that, like if effectively you can call a non-const method on some other class, even if you have a reference to it, that confirms like the compiler isn't considering, like it isn't flowing that const through to other things that you make on other classes.
Right.
Yeah, I think so. Yeah, I think const on CPP value just means you cannot assign a value to S, which is a member of CPP value. You cannot assign a value to that pointer, but the pointer that you already have, you can pass that into functions that require a const pointer or into functions that don't require a const pointer. You can pass it in either way, and to get property, get underscore property and get set underscore property, they do not require a const pointer, which is fine because you don't have a const pointer and you can pass it in just fine, right? The class, the constness of the entire class and the constness of the method does not propagate to S. That's the thing.
I guess like what? Yeah. Sorry, go ahead.
It's like the constness ends with S, and I think what makes it not propagate is the fact that S is a pointer, right? Because then you cannot follow. You cannot follow the definition, and you mustn't, because it's a pointer, it's memory, and that's it. Memory doesn't have any annotations.
I guess just what would make it convincing to me is if we see it's like purely C++, but we're effectively doing the same thing and the compiler is not complaining about it, like then I think that's the thing that makes me say, okay, yeah, I can see that the compiler is not. And whereas if we switch to C or whatever, then you start to worry, well, wait a sec, is it because we're breaking that barrier or whatever? But if it's purely C++ and it's like, basically I can construct the C++ code that is a const method that says, I can do, get X on the class. I can then, and that get indirectly gets the state from some other C++ object. And then I do another const method, and then I call the get again, and it's a different value. Then I think C++ isn't enforcing things and therefore couldn't be, relying on non-state change somewhere else.
Okay, I can add this example, but
Okay. Okay, thanks. I think we're getting pretty close to understanding.
Yeah. For what it's worth, one thing that you can do to make sure that constness is kosher, so to speak, is to compile with minus w cast dash qual, which means complain whenever there's an unsafe cast that discards qualifiers, whether that cast is explicit or implicit. So sometimes there are implicit casts that happen, right? And if you add this minus w cast dash qual, then you'll get a warning whenever you do an unsafe cast, and most often that is casting away const accidentally. That's the 99% case as far as I know of unsafe casting. So if you add that, then you will have your answer as to whether the compiler considers something to be safe or not. And I just built this with minus w cast qual, and it didn't complain. So this is indeed perfectly legal as far as I can tell.
yeah, thank you for confirming.
Okay.
Yeah.
Yeah. If you do that, and then hopefully we can write it all down so that we remember and have we can clearly say, like, here's an example. This is okay. Then all this other stuff is okay. And then
I think in general, what we should aim for when we're making these like language-based decisions is to keep in mind that there are folks out there who compile this code with the most pedantic and most paranoid flags available in the compiler, and our code has to pass that check, and then based on that we can make this decision, which makes me think maybe we should crank up the paranoia on our build system. We should add all these flags, because minus w all is not all. We should add some more flags.
Yeah, if we can have higher levels that are useful, we should certainly consider.
Yeah, I think so. And we might even uncover some warnings that we've always had and that are easy to fix without changing behavior, and to make for better code quality.
Yeah.
Okay, so we're actually 2 minutes past the time.
I have a very quick question.
Go for it.
It's the issue in Node add-on API number 1000. It's number 1000.
Yeah, I probably could have gotten there faster, but here we go. 1000, right?
Yeah.
Yep.
I have digged into the V8 version history, and I identified one patch that fixed the side effect calling in a side effect free debug evaluate call. So, but I'm not sure what is the process about the backporting V8 patches. To what I know,
do
this, So this, luckily, this patch doesn't break any API interface. So I'm just wondering, how do we backport V8 patches?
How much risk do we think there is of breaking something else?
I just take a look into the patch, and I didn't find it change many things. It's just about the debug evaluate.
Okay.
So probably we need another person from the Node V8 team to review it. But yeah.
Yeah, like if you think it's relatively low risk, I think like basically providing a PR with the backport and having the discussion in that issue is probably the best bet. And if it's relatively low risk and low in scope, then I suspect it's got a reasonable chance of landing. I think 12, maybe not. Like 12 is close enough to being out of service that maybe it's not worth doing it there, but 14 still has more than a year left.
Yeah, right. So
Kind of like if it was 16, I think it would be the easiest. 14 is a little harder, and 12, I wouldn't even bother to try and push just for a few months.
okay.
For what it's worth, the more versions we can cover, the better, right? I mean, even if it's not perfect, sooner or later these versions will be the LTS versions, and sooner or later they will be the maintenance versions. So it's benefit either way. It's just how much can we maximize the benefit, right?
Yeah, it's like 12 goes out of service in a couple months, and that's why I'm like,
Yeah,
14,
makes sense.
I think, for 16 months or whatever it is, we have a stronger case to actually, because there may not even, like the older they get, the less frequent releases are.
Of course, yeah. And,
So
and the more they concentrate on like essential security features. Right?
Exactly. Like I think 14 is already in maintenance, but release, let's just go there. So we're 14, yeah. So basically 12 and 14 are both in maintenance.
Mhm.
But that's where, like, if it's small enough and it's in low enough risk, then maybe people will be like comfortable. If it was huge, the answer would probably be no. But I think that one's worth like submitting the PR if you've pretty much got it, and see what other people think as well.
Yeah, sounds good.
And it's already fixed in 16, right?
Yeah, it's landed with the V8 version bump.
Right. Yeah. Okay. So right. So yeah, I think just that backport to 14 could make sense, and so I'd open the PR and see what people think.
Yeah, sounds great.
Okay. Yeah. No, thanks for digging into that and identifying the specific thing, and Jack also for like getting it down to the point where we knew it was in, where to look in at the V8 changes. Any other things we should talk about before we close out? Otherwise, we'll defer everything to next time.
I'm good with that.
Okay. Well, thanks everybody for your time and the good discussion. We will talk to everybody next week.
Talk to y'all later.
Thank
Bye.
you.
Bye.
See you later. Bye-bye.
Bye.